Hello guys, today we are going to learn about ideal and non-ideal solutions, the part which is very important and theoretical part from chapter named solution number 2 from your textbook, 12th standard textbook. This mixture of two volatile liquids, they always actually obey Raoult's law with this type of equations. I hope you know partial vapor pressure of one component is P01x1 and partial vapor pressure P2 is P02x2, and Raoult's law states that the total vapor pressure of both the volatile components like benzene and toluene will be equal to P01x1 plus P02x2. Now guys, these solutions are actually divided into two types of solutions, one ideal solutions and another one non-ideal solutions. Actually, when I say ideal solution असा as such कुठल्याच सोल्युशनच्या मिक्सचरला म्हणजे लिक्विडच्या मिक्सचरला 100% आयडियल म्हणता येत नाही. You can say that this mixture is showing near to ideal behavior. The such example is benzene and toluene. आता कुठल्या मिक्सचर्सना लिक्विडच्या volatile लिक्विडच्या मिक्सचरला आयडियल सोल्युशन म्हणतात. The forces of attraction and the magnitude of forces of attraction are, if similar, are comparable, then such liquids can form ideal solutions. For example, benzene and toluene. If you consider benzene molecules, there will be van der Waals force of attraction between two benzene molecules. Toluene, again, between two toluene molecules, there will be van der Waals force of attraction. So the magnitude of force of attraction, intermolecular forces of attraction are same. So energy required to break these forces, whatever you require, that energy is suppose X amount of energy. Now when you mix benzene and toluene, the new forces of attraction which will be formed between one benzene and one toluene molecule is again van der Waals force of attraction. It's nothing new. So again energy evolved will be same as the energy supplied to break the van der Waals forces of attraction between two benzene or two toluene molecules. So that's why these mixtures, benzene and toluene or N-hexane, N-heptane type solutions will form ideal solutions because the intermolecular forces of attraction after mixing, their magnitude will be same as intermolecular forces of attraction before mixing between two benzene or two toluene molecules. And since they are same or similar, they obey Raoult's law at all composition. So their total vapor pressure always lie between vapor pressures of the two pure components. That means when you mix benzene and toluene in any composition, the total vapor pressure of mixture will always lie between vapor pressure of pure benzene and vapor pressure of pure toluene. That's why they are called ideal solutions. There is one more important condition you have to always talk about, that is whether heat will be absorbed or evolved after mixing. So there is no heat change occurring when you prepare such ideal solutions. Why? I told you just now that when you want to break van der Waals forces of attraction between two benzene and van der Waals force of attraction between two toluene molecules, some X amount of energy is required. And after mixing the two liquids, when benzene and toluene molecules again form the same van der Waals force of attraction, same X amount of energy is evolved. So net energy change is zero. That's why delta H mixing is zero. Now since intermolecular forces of attraction are same before and after mixing, the distance between the two benzene molecule, two toluene molecule, and after mixing one benzene and one toluene molecule also remains same. So the sum of initial volume, suppose benzene is 50 ml and toluene is 50 ml, after mixing the two solutions, the final volume of the mixture will remain 100. It will not become 98 or 102. The final volume will not increase or decrease. So total volume after mixture and before mixture remains same. That's why change in volume is zero. So this is all about ideal solutions. So mainly ideal solutions should obey three main points. They should obey Raoult's law. The total vapor pressure should always lie between P01 and P02. There is no heat change when mixture is done. and there is no change in volume. Now guys, the next part is non-ideal solutions. Now there are two types of non-ideal solutions. One is called as non-ideal solution showing positive deviation, and another type showing negative deviation from Raoult's law. That means they will not give you the equation value P naught P total equal to P naught 1 x1 plus P naught 2 x2. This is not going to be obeyed by these solutions. So let us first discuss the solutions which form or which show positive deviation from Raoult's law. Now, which kind of mixtures will show this positive deviation? See, if I give you example of ethanol and acetone, you remember ethanol has hydrogen bonds between two ethanol molecules, which is the stronger force of attraction. Acetone molecules will have dipole-dipole interactions, which is again a stronger but slightly weaker than hydrogen bonding. Now, when you mix these ethanol and acetone, the problem is the hydrogen bond between two ethanol molecules and the dipole-dipole interaction between two acetone molecules will break, because acetone molecules will come between two ethanol molecules and ethanol molecules will come between two acetone molecules. Since the forces of attraction which were present initially are now not available after mixing, their escaping tendency after mixing, their escaping tendency into vapor phase increases. So, number of molecules going into vapor phase will be greater than expected by Raoult's law. And since these A-B interactions means the interaction between ethanol and acetone, these new forces of attraction are weaker than the forces of attraction between original ethanol and original acetone, therefore, they do not obey Raoult's law. Since more molecules are going to evaporate and more molecules will escape into the vapor phase, the partial vapor pressures will be also greater than expected by Raoult's law. And the total vapor pressure given by the mixture will be also greater than that expected by Raoult's law. Because don't forget, the forces of attraction between ethanol and acetone, newly formed forces of attraction, are weaker than original hydrogen bonds and dipole-dipole interactions. So, हे जे नवीन फोर्सेस ऑफ अट्रॅक्शन वीकर असल्यामुळे जास्त मॉलिक्युल्स इव्हॅपोरेट होतील आणि हे जास्त मॉलिक्युल जास्त व्हेपर प्रेशर एक्झर्ट करतील. So, total vapor pressure will be found to be greater than this, and hence it is called as positive deviation. Partial pressures are also higher. आता जे नवीन फोर्सेस ऑफ अट्रॅक्शन झाले ते वीकर असल्यामुळे तुम्हाला मगाशीच मी सांगितलं की जेव्हा तुम्ही इथेनॉल मधले फोर्सेस ऑफ अट्रॅक्शन ब्रेक करायला एक्स अमाउंट ऑफ एनर्जी वापरणार आहात, ॲसिटोन मधले फोर्सेस ऑफ अट्रॅक्शन ब्रेक करायला वाय अमाउंट ऑफ एनर्जी वापरणार आहात. सो टोटल एनर्जी तुम्हाला लागली एक्स प्लस वाय. आता जेव्हा इथेनॉल आणि ॲसिटोन हे दोघांमध्ये एक वीकर फोर्स ऑफ अट्रॅक्शन जनरेट होणार असेल, then less amount of energy is evolved when new force of attraction is formed, and that less amount of energy is definitely going to be less than x plus y. So net energy gained obviously than energy evolved, because we required more energy to break intermolecular forces of attraction between two ethanol and two acetone than energy evolved when a weak forces of attraction develop between ethanol and acetone after mixture. So हे लक्षात ठेवा की मिक्सिंग केल्यानंतर त्यांच्यामध्ये जी हीट इव्हॉल्व होणार आहे, कारण नवीन फोर्सेस वीक जनरेट होणार आहेत, त्यामुळे वीक लेस स्टॅबिलिटी असणार आहे, कमी एनर्जी इव्हॉल्व होणार आहे, आणि कमी एनर्जी इव्हॉल्व झाली आहे दॅन एनर्जी रिक्वायर्ड टू ब्रेक ओरिजिनल फोर्सेस. त्यामुळे नेट एनर्जी इज गेन्ड, डेल्टा एच इज पॉझिटिव्ह, द चेंज इज एंडोथर्मिक. म्हणून डेल्टा एच मिक्सचर ग्रेटर दॅन 0 म्हणले, दॅट इज डेल्टा एच पॉझिटिव्ह. नाव गाईज, द लास्ट पॉइंट, what happens if the forces of attraction are weaker between ethanol and acetone? हे जे नवीन फोर्सेस वीकर असल्यामुळे ऑब्वियसली आफ्टर मिक्सचर द टू मॉलिक्युल्स आर गोइंग टू बी अवे फ्रॉम ईच अदर. पूर्वी त्यांच्यातले फोर्सेस स्ट्रॉंग होते, त्यामुळे मॉलिक्युल जरा जास्त जवळ होते. But after mixing, the new forces of attraction are weaker. That's why molecules are slightly moving away from each other. So obviously they will occupy slightly higher volume than expected. So suppose initially you have taken 50 ml ethanol and 50 ml acetone, the total volume should be 100. But it is quite possible that since the new forces of attraction are weaker, molecules are moving away, the new volume may be 101 ml. So thoda sa there will be slight increase in the volume. This is just an example. So delta V of mixture is greater than 0 because there will be positive change. 101 minus 100, change in volume is positive 1 ml. So that's why delta V of mixture is greater than 0. So this is all about solution showing positive deviation. Let us move on to last part, which is solution showing negative deviation. Guys, remember, when I take example of acetone and chloroform, such type of solutions will be always non-ideal solutions showing negative deviation from Raoult's law. Now, why they behave like that? Because originally there will be van der Waals, no, slight van der Waals, but there will be more dipole-dipole interaction forces between original liquids, acetone or chloroform. But when you mix them together, don't forget a stronger force of attraction, that is hydrogen bond, is generated between the two molecules. So what happens is the new forces of attraction which are generated between acetone and chloroform are stronger than original forces of attraction between two acetone molecules and two chloroform molecules. Since the new forces of attraction are stronger, their escaping tendency into the vapor phase will decrease. That means number of molecules escaping into the vapor phase will decrease, and hence their partial vapor pressures, individual partial vapor pressures will be also less than that expected by Raoult's law, and the total vapor pressure will also be less than expected by Raoult's law, because you have learned this fact that the new forces of attraction between ethanol and chloroform are stronger hydrogen bond than the original forces of attraction. Chloroform and acetone will have stronger hydrogen bonds. So obviously less molecules will escape into vapor phase than expected by Raoult's law. Since less molecules will escape, vapor pressure will be less than expected by Raoult's law. Now how it will affect the enthalpy change and volume? Just see. If the number of molecules escaping in the vapor phase are decreased because the new forces of attraction developed are stronger, if new forces of attraction, hydrogen bond is stronger than the original forces of attraction. हे बघा, या original forces of attraction पेक्षा हे जे नवीन forces of attraction, the new forces of attraction are stronger hydrogen bonds. Therefore, see, amount of energy evolved will be more. Amount of energy evolved will be more because more stability is achieved. Stronger forces of attraction are developed than original. So while breaking the forces of attraction between two chloroform and acetone molecule, if you have supplied X and Y amount of energy, and when you mix chloroform and acetone, now forces of attraction are stronger, more energy will be evolved than X plus Y. So net energy is evolved. So process is exothermic. Delta H of mixture is negative. So don't forget that in negative deviation, delta H value will be also negative. And finally, since the new forces of attraction are stronger, the two molecules will come closer after mixing. And since they will come closer than original two chloroform and two acetone molecules, since they come closer, the final volume will be less than the expected sum. For example, if I take 50 ml of chloroform and 50 ml of acetone, since the forces of attraction are now stronger after mixing, chloroform and acetone molecules will come closer and the total volume will not be exactly 100 but slightly less than 100, maybe 99 ml. And that's why the difference between final volume and initial volume, 99 minus 100 will be -1. So delta V of mixture is going to be negative, that is less than 0. सो गाईज थोडंसं समअप करतो आणि एक छोटीशी आयडिया तुमच्या डोक्यावरती ठसवायचा प्रयत्न करतो की ज्याच्यामुळे तुम्ही हे सगळ्या गोष्टी फटकन लक्षात ठेवू शकता. डिफरन्स बिटवीन पॉझिटिव्ह अँड निगेटिव्ह डेव्हिएशन. जेव्हा तुम्हाला पॉझिटिव्ह डेव्हिएशन एक्सप्लेन करायचं असतं तेव्हा थेरॉटिकल क्वेश्चन्सचे आन्सर लिहिताना एंट्रन्सला तुम्ही हे लक्षात ठेवा, पॉझिटिव्ह डेव्हिएशनमध्ये सगळी प्रेशर्स ही ग्रेटर दॅन रेऑल्ट्स लॉ असणार आहेत. हे बट ऑब्वियस आहे. डेल्टा एच पॉझिटिव्ह असणार आहे, डेल्टा व्ही पॉझिटिव्ह असणार आहे. हे सगळे ग्रेटर दॅन साईन्स आहेत. जस्ट ऑब्झर्व दिस. P1 greater than P01 x1, P2 greater than P02 x2, P total greater than P01 x1 plus P02 x2, delta H greater than 0, delta V greater than 0. So positive मध्ये सगळ्या गोष्टी ग्रेटर दॅन 0 आहेत एक्सेप्ट फोर्सेस ऑफ अट्रॅक्शन दॅट इज लेस दॅन, आय मीन वीकर दॅन ओरिजिनल फोर्सेस. सो ही आयडिया लक्षात ठेवा. सगळे जे इफेक्ट्स आहेत ते ग्रेटर दॅन आहेत आणि त्याचा जो कॉज आहे तेवढा फक्त लेस दॅन आहे, एवढं लक्षात ठेवा. ही सिंपल आयडिया आहे. मग तुम्हाला इथं पण त्या आयडियाचा ऑब्झर्व करता येईल की निगेटिव्ह डेव्हिएशनमध्ये सगळी प्रेशर्स लेस दॅन आहेत, पार्शल प्रेशर्स, टोटल प्रेशर्स लेस दॅन आहेत, डेल्टा एच लेस दॅन 0 आहे, डेल्टा व्ही लेस दॅन 0 आहे. सो सगळे जे इफेक्ट झालेले आहेत, प्रेशर कमी झालंय, डेल्टा एच लेस दॅन 0 झालाय, डेल्टा व्ही लेस दॅन 0 आहे, पण त्याचं जे कॉज आहे तेवढंच फक्त ग्रेटर दॅन आहे, हे लक्षात ठेवायचं आहे. Forces of attraction stronger than initial forces of attraction. So this is a simple idea on the basis of which you can solve many theoretical questions based on non-ideal and ideal solutions. I hope you have understood this simple idea and you have understood the concept of non-ideal and ideal solutions. Thank you. Don't forget to subscribe our channel for such knowledge giving videos, good ideas, and for help for your entrance exams towards NEET or JEE or CET. So NEET JEE CET मध्ये चांगला स्कोर करण्यासाठी आमच्या देवधर क्लासेसच्या अशा नॉलेज गिविंग व्हिडिओजना बघण्यासाठी आमच्या चॅनेलला सबस्क्राईब करा. लिंक खाली दिलेली आहे. थँक्यू.